Welcome guys, today is Thursday. If you are tuning in online for us, you're going to be doing an electronic lab today. So here's how we find it. Remember, we want to go to modules. It is Thursday, so we are on day 4, which this will be relabeled in a little bit. Kepler's laws experiment. So if you're tuning in electronically to the recorded version of the experiment, you'll use the results of the virtual experiment to gather your data. Be sure to answer the questions on the data sheet. Note, to edit the data sheet, you'll need to make your own copy. There's a PowerPoint for exactly how to do that. The data sheet is right here. Be sure you are also completing the questions. There's 10 points total. There's actually more than 10 points. For this assignment, you will give me a link. Be sure to change the share settings of the document. See the PowerPoint on how to change the share settings. Even though you may work on this with a partner, you must create and submit your own document. Okay, so let's see what this lab sheet looks like. The very first part is an actual experiment, so you are going to go, you'll first make your copy so that you can edit this. So this is the material that I used to make the experiment. If you have the material, you're welcome to try and do the experiment on your own. You just need cardboard, string, thumbtacks, and a colored pencil or a marker, and a ruler. So you're going to place the cardboard backing under the drawing paper, just have the cardboard down. Near the middle of the paper, you're going to press 2 thumbtacks into the paper about 10 centimeters apart. Here, your thumbtacks act as 2 focal points, or focus points. One of the thumbtacks represents the sun. Draw a sun around the left thumbtack. The other will stay, and this one will stay in place. Place the loop over the thumbtacks while holding your pencil vertically inside the loop of the string. Stretch the string until it is fairly taut but not so taut that you dislodge the thumbtacks. Keep the tension in the string and move your pencil around the loop to form an ellipse. So you're going to actually be drawing an ellipse with this thing. If you're tuning in electronically and you don't want to do this experiment on your own, you can watch the video and I've already done this for you. You repeat it, moving the thumbtacks in closer and closer together until eventually they are right on top of each other. So here's the questions where they start that you need to answer. I want you to compare and contrast the 4 ellipses that you have drawn. So what is different or what is similar about these ellipses? You're going to describe how moving the foci closer together changed the shape of the ellipse. So as we got closer and closer together, what happened to the shape of the ellipse? What happens to the shape of the ellipse when the 2 focal points are moved further apart? So that's one point. How could this relate to our solar system? So think about that Mercury is much closer to the sun, the focal point, than say Jupiter or even Saturn, right? What does that mean about the ellipse shape of Saturn versus the ellipse shape or the orbit of Mercury? And then lastly, explain why a perfect circle is a type of ellipse. How does this work? That's going to kind of visualize to you Kepler's first law. For Kepler's second law is the law of equal area and equal time. You're actually going to go to this link. It's going to bring up a kind of simulator for you. You're going to follow the instructions. So click on Kepler's second law and click sweep continuously. So click Kepler's second law, start sweeping. Okay. Use the mouse to change the eccentricity of the orbit. Remember, eccentricity we said we defined as the, what did we define as? We defined it as the focal points of your ellipse. There's more to it, but that's what I can remember right now. So what happens as you move it towards 0? Let's go back. So what happens as we move this eccentricity towards 0? What happens as we move it towards 1? What's happening? Okay. So you're going to answer those questions. Then you're going to set it for a value between 0.5 and 0.6, and then you're going to click Start Animation. 0.5 and 0.6, and then you're going to push, you would push Start animation. What is the value? What happens as the planet moves further away from the sun? So what's happening? As this is the planet, that's the sun. What's happening as they move further away from it? So you're going to answer that. What's happening to the movement? What happens as it moves closer to the sun? You are then going to click Start Sweeping. So sweeping is sweep continuously. Start sweeping. So what's happening? Start sweeping. Okay. What is the area of each sweep? How do the areas of each web compare? Find the area. The sweep area is 1.161 square AUs. That's the duration. So answer those. And then lastly, summarize Kepler's second law in your own words. Kepler's third law, you are going to be calculating your age on the different planets. So remember we talked about Kepler's third law is this idea that the further away a planet is from the sun, the longer it's going to take for the planet to orbit the sun, have a year, right? So here's what you're going to do. Background, your birthday is actually a celebration of a trip made by the Earth around the sun one time. Each trip around our star, we age 1 year, or at least that's how we humans express it. How old are you on the 8 planets in our solar system? If a planet is closer or further away from the sun, will it affect how old you are? Figure your age in Earth days. Your age times 365.2. The 0.52 is because of the leap year, right? If you are less than 6 months from your next birthday, round up a year. Your age in Earth days is what? For the chart, so that would be your age calculated by that number, it would go right there. For the chart below, divide your age in Earth days by the number of Earth days in a planet's year. The answer is your new age. For example, for a person that is 20-year-old on Earth, you would calculate their Earth days by 20 times 365.2. Then you would take your Earth days divided by the number that you are old, divided by the number of Earth days in Mercury's year. So that's 88, and that number is 83. So a 20 Earth year old person would be 83 years old on Mercury. So that's what you're going to start writing down. So you take your age in Earth days and divide it by each one of these numbers, and that is your age on the other planets. The second part of this is I want you to look at the chart below. It has the data about when Earth is in its alpha helium and when it is in its perihelion. Okay? So I want you to answer these questions. During what season is the northern hemisphere in the perihelium? During what season is the northern hemisphere in the alpha helium? Based on this data, do you think alpha helium and perihelium affect the seasons on Earth? Yes or no, because give your evidence. According to this table, what specific date will the Earth be moving the fastest in its orbit? Date, because. According to the table, on what specific date will Earth be moving the slowest? Date, because. So you will find one of these dates where it will be moving the fastest or the slowest, and you're actually going to be basing that on how close or how far away the sun is, right? So refer back to your notes for this to figure out what alpha helium is and perihelium is. If you have any questions, email me or Canvas message me. My very first question is going to be, did you watch the video? Have a great day, guys.